Hello everyone, I am Iswariya, Assistant Professor, Department of Mathematics, Dr. SNS College of Arts and Science. Today we are going to see a case study problem in t-test. In the previous video, we are seeing some problems and what are the definitions and formula for the t-test. So in this video, we are going to see a case study problem. So the problem is the score of 10 candidates prior and after training are given below. So this is the data for the prior and after training. So the prior training values are 84, 48, 36, 37, 54, 69, 83, 96, 90, 65. And the after training values for the 10 candidates are 90, 58, 56, 49, 62, 81, 84, 86, 84, 75. We have to test whether the training is effective or not. Use paired t-test at 5% level of significance. We have to find the values. So first we have to collect the given data which is given in the question. Here total there are 10 candidates. So the sample size for this problem is 10. Next we are going to collect the values. That values for the prior training scores are which is given in the question. So we are going to collect that values, and the next the after training scores which is also given in the question, and then we also collect that values also. In the question itself they given the value for the degrees of freedom. So the degrees of freedom value will be 9, and we have to check this problem for the 5% of significance level. So next we are going to define the hypothesis. So first we assume the null hypothesis. So the null hypothesis is that this training has no effect. So in the opposite case we define the alternative hypothesis. So the alternative hypothesis is training is effective. So we are going to find which hypothesis is correct using the t-test. So the formula for the t-test is t is equal to d bar by sd divided by root 10. So first we are going to find the what is the value of d bar and sd. So first we are going to find the di value. So the di value is nothing but that is after score minus the prior score. So here totally there are 10 candidates. So first we are going to define the prior score. After that we are going to define the after score in the third column. Next we are going to find the di value. So to find the di value we have to subtract these values. We get a value for the di value. Next we are going to find the sum these all di value by getting the summation di value as 63. So the d bar value will be summation of di by n. So summation of di value will be 63 and the n value will be 10. By dividing these two we get an answer as 6.3. So now we obtain the value d bar is equal to 6.3. Next we are going to find the standard deviation, that is SD value. So the formula for the SD value is root of summation di minus d bar the whole square divided by n minus 1. So first in the first column we define the di value which is we obtained in the previous step. Next we are going to find the di minus d bar. So the d bar value is 6.3, which is we found previous steps, that is d bar value is 6.3. So we subtract that d bar value to the di value and we obtain an answer. Next we are going to find the di minus d bar the whole square. By squaring all these value we get in the column of di minus d bar value. In the formula they ask for the summation value. By summing up all these value we get an answer for the summation of di minus d bar the whole square. The value is 728.4. Now we obtain all the values, so we are going to substitute the values in the given formula. So instead of summation of di minus d bar the whole square we substitute 728.4 and n value is 10. By simplifying these value we get 10 the SD value as, that is the standard deviation value as 8.99. Next we have to calculate the t statistic. The formula is d bar by d bar by sd by root 10. By substituting all the values which we obtained in the previous step, we get the t value as 2.22. In the question itself, they given the degree of freedom's value is 9. We have to calculate the value at the bottom 5% significant level. Using the table, we obtained in value was 2.262. By comparing both the values, that is the calculated value as well as the table value, the calculated value is 2.22 and the table value is 2.262. Comparing these two, our value, that is the calculated value, is less than the table value. So we accept the hypothesis. Therefore, the training is not significantly effective. Thank you.